Welcome to all. In this lecture, we are going to discuss about Schottky diode. Schottky diode, another name for Schottky diode is hot carrier diode. It is a semiconductor diode with very fast switching action but a low forward voltage drop. When a current flows through the Schottky diode, there is a small voltage drop across the diode terminals. In a normal PN junction diode, the voltage drop is between 0.6 to 1.7 volts. But in the case of Schottky diode, the voltage drop normally 0.15 to 0.45 volts. This lower voltage drop provides higher switching speed and better system efficiency. In Schottky diode, a semiconductor metal junction is formed between semiconductor and metal. This semiconductor metal junction acts as Schottky barrier. Here, in the case of semiconductor, they are using N-type semiconductor. This N-type semiconductor acts as cathode and the metal acts as anode. This is the construction of Schottky diode. Metal semiconductor junction is formed at one end. This is metal. This is N-type semiconductor. This junction is formed here. At the one end, metal semiconductor junction is formed. This end acts as anode. And here, ohmic contact, metal ohmic contact is made with the surface of semiconductor. This is other end. So this end acts as cathode. So this is the configuration of Schottky diode. This is the voltage current characteristics. So this is applied input voltage along x-axis, output current along y-axis. In the case of normal PN junction, the voltage drop is higher. But in the case of Schottky diode, there is a lower voltage drop. This is the main advantage of the Schottky diode. The forward voltage drop of Schottky barrier diode is very low compared to normal PN junction diode. Forward voltage drop of the range of 0.3 to 0.5 volt. Forward voltage drop increases at the same time increasing the doping concentration of N-type semiconductor. This is the VI characteristics of diode. This Schottky diode used in many places. So it is used in clamping applications. It is used in solar panels, and it is used as rectifiers in power supplies. You just once go through and write the applications of Schottky diode. Next, we will briefly discuss about rectifier. Rectifier, it is an electrical component that converts alternating current to direct current. Rectifier allows an electrical current to flow only in one direction. The process of converting alternating current to direct current is known as rectification. A rectifier can take several physical forms such as solid state diodes, vacuum tube diodes, mercury arc valves, silicon control rectifiers, and various other silicon based semiconductor switches. So the conversion of alternating current to direct current rectifiers are used. Transistor. Transistor, you know that it is a device. It is a 3-terminal semiconductor device. It has the terminals emitter, base, collector. Emitter is represented by E. Base is denoted by B. Collector is denoted by C. The transistor can work in 3 different regions. One is active region, second one cutoff region, third one saturation region. Transistor are turned off in the cutoff region. and transistors are turned on while working in saturation region. Transistors work as amplifier while they work in active region. So while they work in active region, transistor act as amplifier. The main function of transistor as an amplifier is to enhance the input signal. The application of transistor amplifier circuit mainly involve in audio, radio, optical fiber communication, etc. Transistor configurations are classified into three types. We know that common base transistor, common collector transistor, common emitter transistor. But common emitter configuration is frequently used in the applications like an audio amplifier, because in common base configuration the gain is less than 1, and in common collector configuration the gain is almost equal to 1. So this is the transistor amplifier circuit. Transistor in amplifier circuit. This is the transistor, this is base, this one is emitter, this one is collector. In this circuit, for accurate amplification, always remember that the input is connected in forward bias. Here, input is given in forward bias. Here the output is connected in reverse bias. Here the output is connected in reverse bias. For this reason, in addition to signal, we apply DC voltage in the input circuit as shown in the above circuit. So in addition to input signal, we are applying DC voltage also. This input voltage, in addition to this input voltage, we are applying DC voltage here. A little change will occur in signal voltage at the input, which leads to significant change within the emitter current. Because of the transistor act, emitter current change will cause the same change within the collector circuit. The flow of collector current through RC generates a huge voltage across it. Therefore, the applied weak signal at the input circuit will become output in the amplified form at the collector circuit. In this method, transistor performs as an amplifier. That is, we are giving small input and we are collecting at the collector large output. So this method is called amplification. Here transistor performs as an amplifier.